We'll discuss very important concept of transformation of absolute functions in this video. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let us now discuss absolute value functions graph. We are being very specific here to treat absolute functions and the transformations in slightly different way. So we are going to generalize how do we sketch a graph from given function to absolute value of the function and from given function to f of absolute value of x. Now these two things are absolutely different, and many times students struggle to figure out how do we do that. You will understand each and every aspect of this in this particular video. We have taken a very good example, the equation being f of x as x cubed minus x. Now this function is having odd symmetry. So we'll also use the concept of symmetry in sketching of the graph. So many times, if you could visualize the symmetry of the function, then things become much simpler. So those are the strategies which you can learn from my videos and master the techniques. So let's get into this problem now, which is, given the graph of f of x equals to x cubed minus x, sketch the graph of a. Y equals to absolute value of x, b. Y equals to f of absolute value of x. C. Record learnings. Now that is a very important statement. Whenever you do something, you learn. It's important how do we record it so that it can be recalled and then utilized when required. Perfect. Now we have given you the graph of the function x cubed minus x, which is not very difficult to draw, but here the focus is on the transformations. Now the critical point which we wanted to provide you with is the local maximum and the local minimum points, right? From the symmetry, you can see the coordinates of local minimum also, maximum being at around minus 0.58 and y value being 0.38 as shown in the graph. You can always pause the video, answer the question, and then look into my suggestions in which I am going to discuss in details symmetry of the function and transformation when absolute functions are involved. In case you want to learn from me, you can always send an email on the given address. Most of my students are doing extremely well. They are on top of their class, getting awards and scholarships like Akshat.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
Now, let's look into the solution of this particular question. So, give me a moment to discuss the function itself, which is extremely important. So, we are given the function f of x equals to x cubed minus x, right? You can see that this function is odd function. It has odd symmetry. F of minus x will be what? It will be minus x whole cube minus of minus x. And that gives you minus of x cubed and plus of x. If you take minus common, in that case, we do get x cubed minus x. So that means it is minus of f of x. And that means it has odd symmetry. Odd symmetry means it is symmetric about the origin. 180 degrees rotational symmetry about origin. Perfect. So you can clearly see that the part of the graph has the odd symmetry, right? So if I am given the maximum, I also know what is the minimum. It will be at 0.58. The value will be minus 0.38. That is the meaning of odd symmetry. Perfect. So that is a cubic function. You could also graph this, may not get exactly the points. For that, you need calculus. However, graphing is simple, as you could factor. Let me do that for you. F of x could be written as, which is x cubed minus x. You can take x common, and then you get x squared minus 1, and that gives you x common, x plus 1 times x minus 1. Correct? So these are the zeros which are at plus and minus 1. Is that clear to you? So graph is easy otherwise. Perfect. Now let's look into the major question, which is how do we sketch the graph of absolute value of this function? Now absolute value means what? So if I'm saying absolute value of function, in that case it is defined as the function itself if the y value is greater than or equal to 0, right? Or f of x is greater than or equal to 0, right? So we are writing y equals to absolute value of x. Okay. And it is negative of f of x if the y value is negative, right? Where y is the value of the function. Y equals to f of x is given to you, right? So basically what happens is that the negative parts which you see here gets reflected, right? So this gets reflected. So once that gets reflected, what you really get is from here, that you see. And the positive part remains the same. So ultimately, the absolute value function will be positive part remaining the same, which is this, negative part being reflected. So here, this also gets reflected, correct? This is the negative part. So reflected on the x-axis. So this goes right there. You understand? So that becomes the graph of absolute value of f of x. Makes sense? Perfect. So that is how you are going to get part 1 of this. Now let's look into the variation, which is, now we're talking about f of absolute value of x. F of absolute value of x. Now this is a transformation where you could see inside the function it has been changed, right? So if I do that, then what happens to the function? Well, f of absolute value of x will be equal to what? It will be absolute value of x whole cube minus absolute value of x. You get the idea? That is how the function changes. Perfect. Now, in this particular function, all the values of minus x, what will happen to those? Well, let's also look into the symmetry of this function. So if I do f of, this is y equals to, right? So if I do f of minus x, what do I get? I get absolute value of minus x whole cube minus absolute value of minus x. Now, that gives you the same function, which is absolute value of x cube minus absolute value of x. And this is equal to f of x, correct? That means the function which we are talking about, which is f of absolute value of x, is having even symmetry. Perfect. So this function has even symmetry. You get the idea? Now, this is one part of looking into it. When I say even symmetry, means the left side of y-axis is the same as the right side, right? Correct? So whatever is there on this side of the graph remains exactly same on the other side of the graph. That is what it means. Correct? So in this case, on the left side, if I take this very function of absolute value of x, how will you define this? Well, here, if x is equal to when absolute value of x is equal to the value of x itself, when x is greater than equal to 0. Perfect. But it is negative of x when x is less than 0. So it does not really change on the right side. Do you see that? It does not change on the right side. So on the right side, it remains exactly same. Correct? So here, I will draw it exactly same as it was. You see that? Since when x is positive, there is no change. Right? This is one part of it. The second is, when x is negative, then it flips. Then it gets reflected. So on the other hand, it is going to get flipped. And so what are we going to have? We are going to flip this, right? So basically, here is a transformation when the whole graph is reflected on the y-axis. Right? So this graph, which you see on the right-hand side, let me highlight it now, will now be reflected and will be shown here. You see that? And therefore, after this flip, we'll get the graph like this. Do you see that? So that becomes your graph. And you can see that this particular graph does have even symmetry. So when you say the transformation, that is how it is going to be. Perfect. So I hope you understand the concept, how we have done this transformation. Correct? So I hope this concept is absolutely clear. Now let us summarize our learnings. So in this particular video, we are learning how do these transformations from the function to absolute value of x and from function to f of absolute value of x can be summarized. Let's take it one by one. So when we talk about f of x transformed to absolute value of f of x, then what really happens is that if y is equal to 0, no change. So in this graph, wherever it was positive, it remained so, correct? No change. And if y is less than 0, then reflect on x-axis. So we reflected this on x-axis. Make sense? Do you see that? That is how you could summarize in general while you're sketching the function absolute value of f of x for any function for that matter. Perfect. Now let's look into what really happened when we took f of absolute value of x. Right? These are two very different things. Now, in this case, if x is greater than or equal to 0, then there is no change. So that means this part remains same. Second, if x is less than 0, then reflect on y-axis. So we reflect this on y-axis and we get this graph. You see that? Correct? So that is what we mean to say. And that is how you could summarize these learnings. Perfect? So I hope it is absolutely clear. In case you want to learn from me, you can always send an email on the address given. Feel free to write your comments and suggestions. I hope it is useful. Thanks for your valuable time and all the best.